So we have talked about domain and range quite often because it's in every single graph. Linear graphs, straight lines, it's in quadratics that we're going to do in chapter 8. It's in absolute value, the V shape. It's in exponentials, this. So domain and range is never going to go away. And it's really important because we've noticed as Algebra 2 teachers that students are coming in and not being confident in domain and range. And so here in Algebra 1, we're going to stress it a lot and really place importance on it. So we're spending a whole day talking about domain and range, and you're going to love today because it's going to reinforce it, and honestly, it's the same that you've already learned, so you'll be good. So here we go. Domain. Domain is, well, first of all, domain is the x values, but it's going from left to right. And what I do is I ask, or you ask yourself, where does my graph appear? Where does my graph appear when I scan along the x-axis? So I'm going from left to right. It's important that you go left to right. So scanning from left to right, where's the dark line? In some cases, like number 1 and 2, we just have dots. So I'll show you how to do that as well. All right, range. Range is scanning along the y-axis, low to high. And you start, it's like I'm literally going to be up here with my arm going, where does the graph hit? So you're scanning from low to high. We're going to, low would be under the ground, in the dirt, the Earth's core, whatever, negative infinity. And as I scan up, I go up, 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 and maybe the graph goes all the way up to positive infinity. That's range, low to high. So where does my graph appear when I scan along the y-axis? When I go from low, the lowest I can go, up to the highest off the page, right? Infinity is the smallest number that we can describe is negative infinity, and the largest number I can we can describe is positive infinity. So, find the domain and range. All right, we need to do dr for each of these. All right. So, domain. I'm scanning from left to right. So, this is along the x-axis. This is like -5, right? So where does this first dot hit? Along the x-axis. And maybe I've used this in the past with you, but I'll use my clear ruler. No. There it is, the first spot. Negative what? Along the x-axis, what number is this? First dot. -1. So here's how you're going to describe it. You're going to put them into a brace, like not a parentheses, We're going to list them because it's not a solid line. -1, comma. Where's the next place it hits? What's that line? What's that at on the x-axis? Yes, on the x-axis, that's 0. What's this on the x-axis? 2. And then you close your brace. If you need to practice it, it looks like this. That's the left side of the brace. The right side's always the hardest for me. It doesn't ever look as good. But that's a brace, we call it. It's not a parentheses. It's a bracket is the boxy looking one. This is a bracket. This is a parentheses. This is a bracket. That's a brace. Fancy parentheses. Fancy schmancy. Range. Low to high. Low. Nope, 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 nope. Where's that? On the y-axis. What is that hitting on the y-axis? 1, and then again 2. There are 2 dots on the 2, but I'm only going to write 2 one time. Okay. Domain. The number below it, please. Domain, left to right. Nope, nope, nope. Oh, okay, sorry. Here's the axes. I'll do it in purple. Okay. What's that at? -1. Okay. Now, the domain is just one number because this equation of the line, by the way, is x equals -1. That's the equation of the line. Now, low to high. See, this black arrow is going to go forever down. Off the paper. That's down to -infinity. So -infinity. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to positive infinity. All the way up. All the way up. All the way up. -infinity to positive infinity. I always use parentheses when I'm doing infinity. Bracket is for when something touches a line, like a parabola or something. I'll show you on some of the homework problems. We're going to use a bracket for some things. So real quick, parentheses is like an open circle or a dashed line on a graph, and it means included. We've done this before, but it's been a while. Bracket is a closed circle it would be a solid line. Anytime a line touches, like a solid line, and this is, oh wait, I said it, oh my gosh, I said it backwards. Excluded. Included. Infinity always has a parentheses. So if you're writing infinity, it's going to have a parentheses next to it. All right, let's do number 2. 2A and B. Domain. Scan. Up, up, up. -2. -1. 1 and 2. Brace. Oh, it starts at -2, doesn't it? -2, comma, -1, comma, 1, comma, 2. All right, this line, range. -2, -1, 2, 3. Okay. Now, this bottom right corner, the domain, this line is going to go forever to the left. Up, it goes higher and higher, but it's still going to the left. Eventually, this line is going to be at negative infinity. So if I'm scanning from left to right, the line will eventually be where my arm is, but just really high up. It's eventually going to be over there, but really high up. And above Acacia Elementary. And then the next city over is La Mirada. And to the right, it hits, and eventually it goes down, but it's going to the right. So it's eventually going to be down below the ground, underneath Cal State Fullerton, way below, way low. Underneath the city of Placentia, underneath the city of Yorba Linda. That's the next cities in order. So I'm going to do the domain left to right, negative infinity, positive infinity. This is called interval notation. Now range, low to high. Start low. Low to high. It's going to be way low. That's negative infinity. And it's also going to go really high up, all the way. Negative infinity to positive infinity. All real numbers. There's an R with a line down it. It's like a dollar sign, but not an S, it's an R. And this also means all real numbers. So there's two ways for us to represent all real numbers. The negative infinity and comma positive infinity, and then this R is used in math. So I want you to be aware that something else exists. Okay. The next page has no graphs on it because I have to hand draw them. Okay, ready? I am drawing an exponential. I plotted a point at 0, 1, which is the y-intercept, at 1, 2, negative 1, a half. Okay. The domain is left to right. What is this? Left to right. Doesn't it go forever left to negative infinity? So that's negative infinity, and then I'm scanning. It's going to go up forever to the right. That's positive infinity. All real numbers. All right. The line never touches 0. So it is not included, or, excluded is the better word. So it's not at negative infinity. I'm doing range now, low to high. It's not at negative infinity. It's not at negative 1. It doesn't touch 0. It gets really, 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 really close to 0. Remember how I showed you on Desmos last week? How it never, ever touches, but it gets super close. I'm going to use a parentheses 0. And then it goes up high to positive infinity. This is exponential growth because it's going upwards. This next one I'm going to do is exponential decay. It looks like this. Negative 1 up to 0, 1, 1, 1 half. And the third one I'm going to do is going to be an absolute value. That, by the way, is the absolute value of x plus 3. That's the equation. Okay. This one, domain, it is going to go left left, left. So it does hit negative infinity eventually. Scan, positive infinity. From left to right, negative infinity to positive infinity. But the range, my asymptote. Do you want to say it again? Asymptote. It never touches. So it's parentheses 0, comma, and then it goes up, low to high. The lowest point it is around 0 because it gets super, super, super close. The highest point up is infinity. All right. The domain here is no surprise. It's the range on this last one that we need to talk about. The domain from left to right, it's going to hit over here where my ruler is. Yeah. Negative infinity. I just can't draw the line that long because it would go off the paper. To positive infinity. All real numbers. Negative infinity to positive infinity. All real numbers. Okay, low to high. Where does it start? No, 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 no. Oh, what's that? On the y-axis, what line is that? It's awfully boring when I talk to myself. 2, thank you. It touches 2. It's on 2. I'm going to do bracket 2, and then it goes up to positive infinity. Parentheses. Okay? 2, positive infinity. Some people, by the way, you can say y is greater than or equal to 2. That would be a way to write the range. This one, y is greater than 0. That'd be another way to write the range. Okay, let me get this to you really quick because I want to do some of it on the video. Okay, here's the homework page. It's two-sided. It has 18 problems. You are doing the domain and range for each one. And some of the domains and ranges are going to be kind of weird. Like, let's look at number 6. My domain on number 6 from left to right starts at negative 2, bracket negative 2, and then this line goes forever to the right. So I'm scanning left to right. Negative 2, and then it's at negative 1, 0, 1, 2, 3, 4, 5, 6, 7. This line's going to go forever and ever down. So I'm going to put infinity. Bracket negative 2, comma, infinity. Hojin, with me? If it's just dots, you just make a list. $13. What's the domain of 13? What am I going to say for domain for 13? Number 13, what am I going to say? From left, it hits what? Hi, people. From the left, what does it hit? I heard you kind of. What'd you say? Negative infinity. The lines go forever. Negative infinity And where does it stop? -4, -3, -2, -1. It stops at 0. And it touches 0. That's a bracket after 0. How are you doing on this? Does this seem easy or hard? I need you to tell me, please. Like, use your words, please. Okay, I'm going to stop the video. I'll ask you